So what is the method? I'll explain it to you in 30 seconds. It's not complicated to understand. It gets a little bit involved to do the calculations, but at that point, that's just math. So there are two possibilities, right, for the outcome. Either you are wrong about a false positive or you are wrong about a false negative. Well, what you want to do is to minimize the cost of both, right? So tell me what the costs are, and then I'll just minimize the expected loss. So this is the expected loss of the cost under the null hypothesis of a false positive. So the null hypothesis, drug doesn't work, but you approve it anyway. So that means there are side effects, people can die from it, and people wasting money, there are costs. But now here are the costs under the alternative hypothesis. The alternative hypothesis is this is really a good drug, but you did not approve it, which means that people are going to die, they're not going to get access to it, and that's going to be potentially huge for the loss of life and the value that that carries. The probability of the null in the alternative is, we don't know what that is, but let's start off and say it's 50-50. And if you do the math and crank through, what this will do is to tell you how to set your threshold in order to minimize the average cost. So now instead of 1.96, maybe it should be 1.65. Maybe it should be 1.35. But it's not arbitrary. It now minimizes the cost and the benefit. So we did this. We actually applied this and got numbers for how many people die from these cancers, what kind of toxic effects there might be in the case the drug doesn't work.